In this video, we're going to talk about the process of formulating a hypothesis. A good hypothesis is precise, it matches the research question, and it can be tested with available data. We're going to go through each of these conditions with some examples to demonstrate why they are important and also how you can improve a hypothesis to meet them. So first we'll talk about precision. And as a bad example, let's consider the hypothesis: the surface temperature depends on atmospheric carbon dioxide. What are the problems with this? This is very vague. How does the surface temperature depend on atmospheric carbon dioxide? In what contexts would we expect to see a change? We can improve this hypothesis by specifying the nature of the dependency. Next, we'll talk about matching the research question. As an example, let's consider the hypothesis: feedbacks between water vapor and temperature will increase warming as carbon dioxide increases. What are the problems with this? Water vapor goes beyond the scope of the research question defined in video 1. As a result, we should not have a hypothesis that includes it. However, we can return to step 1 and update the research question so that the hypothesis matches. And in that case, this hypothesis is actually okay. It could be a good hypothesis. Finally, we want a hypothesis that works with available data. As a bad example, let's consider the average surface temperature will increase by 4 degrees Celsius by 2100. What are the problems with this? While there is research that has predicted this outcome, we do not have the data until 2100. And an important point to emphasize is that a prediction is not a good research hypothesis until the data is available. If we wanted to make this a better research hypothesis, we would want to specify data sets that we can actually use, whether that's from models or from proxy data or something else. So now let's take a look at a better hypothesis. Because the absorption of long-wave radiation increases with CO2 concentration, proxy data from past eras will show a correlation between higher concentrations of CO2 and higher average surface temperatures. Now, why is this a better hypothesis for our research question? First, the data is available. We have proxy data that show the concentrations of CO2 and the average surface temperatures. Secondly, this is a precise prediction that matches the research question. And then, as a bonus, we're proposing a mechanism for why this hypothesis might be true.